hat off. But it took me 2 weeks before it dropped, and I understood it. Now I do, and it's actually quite brilliant. I will break it down and make it a little bit easier, because I'm pretty sure that is what the people who heard that the first time said. So this comes out of a keynote called Data Abstraction and Hierarchy, I think, from Barbara Liskov quite a while back. And if I heard that, I would have been sitting there going, hey? So the simple conversion of that weird stuff is a subclass should behave in such a way that it will not cause problems when used instead of a superclass. A little bit more sense, right? It kind of means the way, if you inherit a class, once again, we build upon the open-close principle. I inherit a class because I need some new features, new functionality. The changes that I make to my base class in that new class is not allowed to make any changes to the implementation in such a way that it could break any code that's potentially using that implementation at the moment. That's simple, right? Just take it, modify it, but don't make any modification that will cause any changes. Okay? Luckily, there are rules, kind of in quotes. Contravariance of method arguments in a subclass is allowed, and covariance of return types in the subclass. Is there anyone out there that needs explanation of what this means? Yes, thank you. There are a few brave souls going, yeah, mate. The rest of you, you are so lying. Sorry, that's just the way it is. So contravariance of method arguments in a subclass means that if I have a class, I create a new class that inherits from that class, I am allowed to change the input arguments to my method in such a way that they accept a base class of the arguments that my base class accepted. It basically means that I'm allowed to change the input parameters in such a way that any parameters that has ever been passed into the parent type can be passed into the new type. Sweet. Covariance of return types in the subclass means that the return of my class, the return value of my method, is allowed to be any type that is the same as the parent or a descendant class. Once again, I'm allowed to return anything as long as it's at some point inherits from whatever the base class returned. Makes a little bit more sense than that, I hope. The cool thing about this is that it is virtually freaking impossible to do in C#. So we can ignore this. Trust me, I tried. I had a long, hard try, and I had this idea. If I start using dynamics, can I somehow freak out the .NET runtime to a point where I can change my input arguments and my output arguments in such a way that I can get to this? No. Does not work. It makes sense if you're doing pointers and things like that, but if you're actually inheriting things in C# in .NET, it is freaking impossible. And if you have any way of doing it that I don't know of, please come up and tell me after the presentation, because I really want to figure it out. The next one is no new exception types are allowed to be thrown unless that's a misspell, it's supposed to say they, not the y, are subclasses of previously used ones. Pretty much, in your new class, you're not allowed to introduce new exceptions. Why? Well, if you introduce new exceptions, whatever code has been using the other class, your base class, might be prepared to handle whatever exceptions that class is throwing. If you start introducing new ones, things might blow up. Your application might break. Here's another one. Preconditions cannot be strengthened in the subtype, and postconditions cannot be weakened in the subtype. Anyone need explanation of that? It kind of means preconditions cannot be strengthened in the subtype. This is a really poor way of describing it. You cannot be expecting things that wasn't expected in the base class. I cannot make changes so that, hey, you're only allowed to call this method if this property is set to this value, if the base class hasn't had that limitation before. So you're not allowed to introduce things that might cause, once again, any class using the base class cannot break because you've introduced new features or new limitations. And post conditions cannot be weakened means that I'm not allowed to change the class in such a way that you cannot do things you could do before. So I can't start throwing not implemented exception or say you're not allowed to do this or that or whatever, because once again, if I introduce a change like that, code that was using the base class cannot use the new type and might actually fail. And then there's the final little thing called the history constraint. The history constraint means that you cannot make an immutable class mutable. So if you have a class that cannot be changed, you have a property of a class that cannot be changed in the base class, you're not allowed to change that class in such a way that you can change the value in your new class. Because any type or any class using the base class might be expecting that that value can never change. If you all of a sudden start introducing the possibility of changing it, once again, you might be breaking things. So basically, before I go into code, the general guidelines when it comes to listgovs is actually what Miguel said. Miguel did not say I should throw out listgovs completely. He just did not want to admit that there were a bunch of specific rules. The general idea is you are not allowed to change a class in a way that you can break any existing applications. And then you have these rules to define what could break an existing application. So I created a little bit of code, and here is where my demo kind of falls apart. I had to do this in a different way. I could not figure out how to put listgovs into my application. So I've actually created a whole separate little project where you can see listgovs different things, because I couldn't find it in my application. The only place I found it was that thing that I mentioned before. It is that the document storage. That is not acceptable. I cannot start throwing things that the potential clients that were using it before didn't expect. So instead of doing it in that project, I came to the conclusion I will show you the different principles, but I'll do it in a different project. So I've created a little test project to just show that it works, and all of these tests, they work. So covariance and contravariance thingamajigs of this method signatures I just ignored. There was a little dynamic thing in there before, but it didn't work. But I introduced this thing. I've got a car, right? Very simple class. It looks like that. It takes a color, sets the color. It's got start engine, stop engine, and it has a little has fuel thingamajig in there. And the only thing these do is basically, if it doesn't have fuel, it throws an out of fuel exception. Otherwise, it turns on the engine. And if you stop it, it stops the engine, right? That's about as basic as we can get. So I wrote these tests to verify that that class works. Make sure that it can start. Sounds like a reasonable test, right? So I create a new car. I start the engine. I'm looking for out of fuel exception, which should never happen, but yes. And then I make sure that the engine is running, right? That works. Then somebody comes along and says, I'm going to inherit that. I'm going to create a broken car. I have a broken car, and whenever you call start engine, I'm going to throw not implemented exception, because it's broken. It won't start. That is an obvious contradiction to listgovs. Basically, I'm introducing a new exception, and if I were to run this test now, this test will fail, because I'm not expecting not implemented exception. I am expecting potentially an out of fuel exception. I'm not allowed to go in and make changes like that. So I've basically broken the post conditions cannot be weakened thingamajig, because I've changed what you're allowed to do. I introduced a new one, a crime boss car. The crime boss car has another one of those. If I run this, you'll see why that doesn't work. It throws a met your maker exception with the message, boom, you're dead. Because the crime boss car actually has a booby trap. And if the booby trap is set, it throws an exception, right? Once again, I'm throwing exceptions that I'm not allowed to do. Once again, somebody might be using car, I pass in a crime boss car, and all of a sudden my application breaks. I have another one here, another test. Make sure engine is running after start. That seems pretty obvious, right? Turn the key, start the car, engine should be running. Something that an application could be considering to work with and try. So I have a car, I start the engine, it's running. Then somebody comes and creates a Prius. I don't know why you're laughing at the specific Prius, but the Prius. Yeah, so the Prius is different. Anyone own a Prius? Okay, I'm not going to say anything about the Prius. It's a fantastic car. And one of its features is that it doesn't actually start the engine when you turn the key. It turns the engine on and off a little bit back and forth, depending on how fast you're going. It's got an electric motor and all of that. So start engine is overridden and does exactly that. Doesn't do anything. Flips a switch and says whenever the guy pushes the gas pedal, then potentially start the engine if he's not pushing it too hard. So that breaks it again. Minor change. I've just changed what you're allowed to do, but any code that could be using it could be depending on the engine being started after you turn the key. You're breaking it. Somebody introduces a stolen car. Stolen car changes the preconditions. You know stolen cars, I've seen movies. You have to strip the ignition wires first and then combine them to start the car, not just turning a key. So I have this thing. Basically, you have to call strip ignition wires before you can start it. If you don't do that, the car won't actually start. That doesn't seem like a big problem when you're coding it. I'm kind of hard-pressed to find a situation where you would build a class like this. I don't know. But if you were, once again, this test will fail. It will not work. And finally, make sure the car is painted correctly. Have my car, make it red, make sure that the car is red. Could be obvious. That little thing is not possible to change. It's immutable, right? The implementation of it basically just sets a color, which has a protected set, so it's not possible to change it externally. But then I create a pimped car. That should potentially have been pimped out car, but yeah. And I make it red. Then I change the temperature of it, and that changes the color of the car, right? Obviously, because my pimped car uses this cool new, there's a link here that goes to a place. There's actually new paint that you can put on your car that when it gets cold enough, it changes color. So just imagine that I have that car, and if I change the temperature, and the temperature goes below 20, if it goes below 20, I make it black. Doesn't seem like a big problem, but it is, because I might not be expecting that. I'm expecting that color to be constant. That should never be changed, it should be immutable. So I'm violating the history constraint in that case. So as I said, I couldn't get all of it into my existing project, but as you can see, all of these minor little changes, every single time I inherit that class, I make a little change to it, and it breaks. The general idea, this is not going to hold up in all situations, absolutely not, but you should most likely be possible to take your new class and throw it in and run it through all of your existing unit tests, and they shouldn't fail in the way that they break down. You would then have to check, some of them might fail and give you red because you've made some requirement changes and you changed the class and they should be going red, but at least they shouldn't break down. They shouldn't puke all over your test runner and go, I can't run this anymore. That is the basic idea behind Liskovs. So what about abstract base classes and interfaces? That becomes a whole lot more complicated. It's one thing if you're inheriting from a class that actually has an implementation, because you know that that class has basically